Hi folks, this is Linear Algebra, Quiz 18. We're given a definition. A set of vectors in an inner product space is called mutually orthogonal if, whenever you have two different vectors in the set, their inner product is 0. Prove if f is mutually orthogonal, then x is linearly independent. Okay? So we're going to assume x is a mutually orthogonal set of vectors. So x consists of non-zero vectors that have this condition. What do I need to show? I need to show that if I take vectors in x and I have a linear combination equal to 0, then all the constants are necessarily equal 0. So I'll start off with this, and I'll have to conclude this, and I have to somehow use this inner product property. So let's assume we have these vectors in x and then you have a linear combination equal to 0. How am I going to get the CI's equal to 0? Well, I have to somehow get the inner product involved. So I'm going to take the inner product of both sides with, say, xi. So in other words, c1x1 plus c2x2 up to cnxn. Inner product with any of the xi is equal to 0 inner product with the xi. And now I use properties of the inner product. The inner product is a bilinear thing, so it's linear in each coordinate. So the left-hand side can be written as c1 times the inner product of x1 with xi plus c2 times the inner product of x2 with xi on down the line. And we've proved, using properties of inner product, if I take the inner product of 0 with any vector, I just get the number 0. Now I use the mutual orthogonality condition. If xi isn't equal to x1, this inner product is 0. If xi isn't x2, this inner product is 0. So the only thing that's going to survive over here is ci, xi, inner product with itself. Now we have a property of real numbers. This guy's a real number, and this guy's a real number. The only way the product of two real numbers is 0 is if the first one is 0 or the second one is 0. Well, by properties of inner product, or really definition, I should say, of inner product, this is equal to 0 if and only if this is the 0 vector. But I'm assuming I've got a set of non-zero vectors. That means this has to be what's true. So what have I shown? If I have a linear combination equal to 0, then c sub I has to be 0 for all I. And that's exactly what I needed to show for linear independence. So that'll do it for Quiz 18.